Hello everyone, welcome on my YouTube channel. Today I'm here with the presentation of the introduction of one project I am going to develop, and share with you a 7-day challenge where I will implement an AI agent application. The application is about users who are logged in and chatting. The application here is going to use the information the user is providing. We will be tracking any interaction of users with the application and take advantage of any information they provide to keep them connected on our application as long as possible. So, for the plan. For day 1, we are going to implement a kind of guardrail. We are going to capture the user inputs, and decide if it's relevant for the application or not. If the user enters something valuable for our application, we process it. But our application only accepts information about content creation. You can imagine this application as a world where content creators exchange with each other but only on topics related to content creation. So when the user enters an irrelevant text, we interrupt the process immediately, telling the user that we cannot answer or process the input. We don't want the application to process other types of information. In day 2, we continue with analyzing user input and extracting useful entities. When the user enters information that is relevant for the application, we are going to use a large language model to extract entities from the texts the users will be providing. The text will be provided either via the chatbot we have in the application, or by sharing the posts, likes, dislikes or comments that the user makes. Because we will give users the possibility to see other users' posts and give some feedback on that. And whenever the user decides to comment on a post, we are also going to extract information about the user. We will use a large language model for this, to extract meaningful information. The LLM will return structured data, in this case in a JSON format. So in day 3, we will work on storing the data. We're going to set up the databases. We'll be using MySQL to store structured information, and Milvus as a vector store, where we are going to store embeddings of longer texts. We will write the logic to insert new users' records and see how to query them. I will code within 7 days. I will do this after my main job, planning to spend about 3 to 4 hours each evening working on the project. I hope that in those 7 days I will complete the implementation. I'm aiming for realistic, focused progress. I hope that in 7 days of effort, I will be done with the project, but I am not sure if this is realistic. Still, I want to give it a try. This is also a learning project. I am using tools I usually don't use. You know, in this Gemini world there are so many libraries and tools popping up every day. And each of them has so many alternatives. I may have experience with alternative options of the tools I will use for this project. For example, I have experience working with pgvector as a vector store, but for this project I decided to use Milvus, because I am curious to know how it performs in this context. For the front end, I will try to build it with Gradio. I never did this before, implementing a front end fully with Gradio. And honestly, I am not even a front end developer, so I am not sure if it's realistic. But I will give it a try. Day 4, we will do data validation. As said in day 2, we will sometimes prompt the LLM to generate JSON data. We will use a Pydantic model to validate this information before storing it in the database. We will see that with Pydantic it is not only possible to validate data fields but also their types. Pydantic makes it very comfortable and easy. This ensures the system is clean and reliable. So after the Pydantic validation we will pass only the validated data to be stored in our databases. Day 5, this is where we implement the agents. The heart of our application. We will implement agents able to generate action plans and execute them fully autonomously. We are going to wrap our Python functions into callable tools. Now you may know that there is a bunch of libraries out there helping to implement agents. They are all very powerful, and some of them are also good for people without coding knowledge. LangChain, N8N, OpenAI, etc. But we are not going to use any of those libraries in this project. In this project, I want to learn, so I decided not to use heavy agent frameworks. If you don't want to get your hands dirty, this project is not for you. But you can still stick around and watch how I struggle. If you want to learn and truly understand the mechanisms behind agentic applications, then get yourself a notebook and code with me. I think the best way to understand how a library works is to implement a skeleton of this library or tool from scratch. We will build the agents from scratch with Python. Define tools, define actions, and let the agent generate a plan and execute it. We will do a lot of prompt engineering in this session. We will face many issues and errors. And I think even if you don't code with me, you may learn some new things for your projects. I will face some errors and will be fixing them live. I will just record everything. I hope you are not going to be mad at me at some point because, let's say, coding can be very boring sometimes. Day 6, the evaluation. Before putting the system in production, we need to evaluate. You don't want to deploy your application without being sure that the application is accurate. This means for NLP applications that you have to be sure that the application provides information the users are really interested in. In a chatbot, you want to make sure the system responds with respect to the user profile, like if the user is an adult or not and stuff like that. You see? We'll measure if the responses are relevant to the user input, if the context is retrieved correctly. In this type of application, the context may be the data you have in your vector stores, the internet, etc. We will also evaluate if the personalization is working. We will use ROUGE-score for that. Day 7 is the wrap-up. We will do an end-to-end demo of the application. We will also discuss possible improvements, optimizations, and future directions. Let's see. I will use tools I never used before, and maybe I will end up saying that some of them are not worth it for me. Or maybe that some of them perform better than the ones I used in other contexts. But I will definitely avoid using the well-known tools. My focus is to build them from scratch using Python. Now let me present you the flow of the application. Let's zoom in for you to see. When users register, they provide information such as age, gender, and preferences. Based on this, we propose content they might be interested in. The frontend has two main columns. The left side is for displaying the content feed. We will display the posts of other users and give the user the possibility to like, dislike, and/or comment. But the user profile changes over time. That is why we are going to track them. As users create posts, comments, or chat, we extract information and update their profile. For example, when the user decides to create and publish a post, we can analyze the post content and, for example, extract the user's recent interest. And we will update the user profile in the database. We will do the same when the user comments on someone else's post, or when the user is interacting with our chatbot, which is on the right side of the front end. Not all input will pass. We don't want to waste resources on input not relevant for the application. That's why we have the guardrail. We will train a Keras classification model, using a dataset generated with a large language model, with examples of input text we accept, and the ones we don't. We will use a very simple Keras model because it is lightweight and can run on modest hardware. It will filter out irrelevant inputs for us. Of course, you can also use LLMs for this task. But large language models are heavy, as we all know. And in this project I want to share alternatives. In the Guardrails implementation, Keras will meet NLP. Once an input passes, it goes to the agent system. We will define the agents from scratch. We will define a register where we will put the tools the agents will have access to. The tools are going to be native Python functions. We will prompt the agents to generate their action plan, and autonomously execute them. We will have two main agents. One will be responsible for the posts feed. The other one for the chatbot. Each main agent has two sub-agents. One to generate the plan, and one to execute it. For example, if a user enters a message via our chatbot, and the message is relevant to the application according to the guardrail, the chatbot agent may check the user profile in the database. Then use the available information on the profile to search for similar posts in the vector store. Then the agent will use the retrieved post as context to generate a personalized response based on the input, the retrieved context, and the user's profile. On the storage side, Milvus will store collections, or let's say embeddings for posts, comments, and user information. The latest is for the case that the application has too many users registered and interacting. It may take too long to search for similarities even just about the user profile, in a MySQL database. A vector store is most appropriate for that. And we will see why during the implementation. Also, we will use a MySQL database, where we will store structured data like user profiles, posts, and feedback. As said previously, the user has the possibility to communicate with the system. Each time the user will take an action, we will analyze and extract what we need. In the users table we will store username, age, gender, and so on. In the posts table we will have the user ID, the post_ID, the content, etc. Here I want to mention that we will only store embeddings in the vector store, as the plain text will be in the MySQL database. This is for avoiding having redundancy in our system. Same will be applied for the feedback the users will be sending. It is missing here, but we will also have a question-answer collection, where we will store the history of the interaction between the user and the chatbot. This could be helpful to improve the performance of the system. So that is the overview of the application. If you are curious to see how far I go with this implementation, stay tuned. As I said, I may not publish every single day, because the project is big. But once the implementation is done, I will edit the videos and share them with you here. That's it for the introduction of this challenge. I hope you will enjoy it. If you have questions or comments, let me know. I am pretty sure that the experts from my audience may already have ideas on where I will fail. Let me know in the comments. Is it realistic? Building this whole application in 7 days? Beside my full-time job? See you later. And as always, happy coding and debugging with K-Tips.